So two groups have done this one and wrote it on the whiteboard and saw that this was in common with both, factored that out. Is there anything else we can do, or are we done? We're done, yes. If it was a subtraction, no, we could go on. Zach, are you done? You guys can write the second. Okay. Is that going to be for the second one? Of course. Randomized, iterate, front split. Okay, so the second one, just got the question, and I see this on a couple of boards. Is that right? These guys say yes, someone else said no. Sasha, what do you think?
It is complete. The negative x and positive x cancel out, it's 3x squared minus 1.
So this pattern, perfect square minus perfect square. Sasha just said, when you do FOIL, first times first, we get that x squared, but outside times outside, and inside times inside, she said, those guys are gonna cancel out, no matter what the pattern is. So this and this, I'm gonna get positive those two things and then a negative those two things. So they're gonna subtract out and I'm gonna get x squared minus 1 back. So difference of squares works. If it's positive, can't do anything. You're done. All right. Kelly, what did you get for this one?
X minus y, x plus y, x squared plus y.
Okay, so she did 2 steps. And she did the whole thing out. First thing she said, perfect square subtraction. So that pattern first. And then she looked at this piece and said, it's another perfect square and subtraction. The second thing was solid, just don't. Okay? Questions on any of those patterns? Yes?
For the third one, why can't you do x minus y and x plus y for the second?
Okay, well, first of all, are those two things exactly the same? No, so this one factored like that. This one does not factor because like Sasha said, when we multiply this part and this part, I get a negative xy and a positive xy, they go away. If I try that with this, if I keep them positive, that's xy plus xy, I'm gonna get 2 of them, they're not gonna cancel out. And I don't have that in there, so I'm done. Other questions on those first 3? Yeah, okay. Have you guys heard this word before, conjugate? That's exactly the same dudes. One is plus, one is minus. And the reason we might need these is for exactly the reason, actually your point earlier is just making the rounds today. It's because those inside ones cancel out. So we might use this as a strategy in our trig identity stuff. Keith, what do I get when I do x plus y times x plus y?
X times y, so you get
First times first,
x squared
outside times outside,
plus xy squared.
plus x times y, and then inside times inside. And outside times outside. Jackson, how do things combine?
X squared plus 2xy plus y squared.
So again, Andreas, this is kind of what you were asking earlier. Kalila, when I multiply this guy out, what do I get?
A squared minus 2ab
So she did both of these,
plus b squared.
and then negative b times negative b becomes positive. So she said this out already combined. Okay? Read factoring, algebra 1. Y'all hated it, it's clear. Dante's expression right now is the Monday math look. Yay! There we go, okay, a little bit, all right. Okay. So, we're gonna have to use some algebra and some stuff. There's an entrance card on Wednesday on proving identities. Hopefully proving is easier than simplifying, because I tell you the end goal. Sam, you're looking either terrified or checked out. We turned the sunlight off for you. Okay, again, this list, long and confusing, so it's easier if we try some. You had 3 textbook problems to do. I'm sure you got right to them. But to show you what's going on with this. First step was, which side looks more complicated? So this Zach, which side looks more complicated in number 12? The left or the right? The left. I agree. So maybe, first thing, multiply to this to everybody. It makes it worse looking. Okay, then maybe the next strategy is turn everything into sine and cosine. Why? Because this side had nothing but sine and cosine on it. So in the end, we need to do that translation. So sine is just sine, but cotangent is cosine over sine. Again, sine is just sine, cosine is just cosine, but tangent is sine over cosine. One of those cancels, one of these cancels, and I'm left with just cosine here and over there, sine times sine. So I get, those guys are equal. Does that work? All right, Leo, what about this one? They both kind of stink. So, would you start on the right or would you start on the left? On the left? Okay. Cool. So, Chloe, from the,
Isn't it negative sign?
close? I know what you meant to say, but you didn't say it.
Oh, okay.
Sine squared, not sine 2x. So, oof. Cosine squared plus sine squared equals 1. Subtract 1 from both sides. Subtract sine squared from both sides. We get what she said. But Sam, the left doesn't look like the right yet. So I need to make them look the same. I'm not allowed to move things to the other side. These are proofs, which means the question, the equal sign is kind of in question. So Sam, what can I do to make this look like that?
Cosine is tangent,
So, sine, you said make it sine over cosine, and then, since this was squared, there's another sign there, and the negative was there. So, you know, what did he say? What is sine over cosine? So, we proved it. Leo, what do you think? Yeah, okay, then, Cleo, how do I do this last one? Which side looks more complicated, first of all?
The left.
Clearly the left. Okay, so multiplying the stuff in the numerator, what do we get?
1 cosine u. Minus cosine u.
Oh, so is this a plus?
Yeah, that's plus and then minus. And then cosine u, no, cosine squared u.
Plus?
Plus. Or no, minus.
Okay. And there's a denominator. Polly, what combines in the numerator? Sorry? In the numerator, what is 1 plus cosine minus cosine squared? What combines? What happens to this and this? They go away, so I'm left with 1 minus cosine squared. Ooh. Dante, so those identities that we're getting better at. 1 minus cosine squared. Sine squared. And Laura, we're trying to get to the other side. What is sine over cosine? If you need help, look at the other side. What do you think it's gonna be? It's gonna be tangent. Sine over cosine is tangent. These guys were squared, so it's squared. So we have the proof. Kinda, sorta? Zach, what do you think? Turn that over again. What's up? You guys are sleepy. Yay for daylight standard time. Eastern Standard Time. Okay. Well, that was a review of the homework. With your group, give this a try. Which side is more complicated, Alexia? Clearly the left side. Andres, what's your suggestion?
You use the non-negatives because one.
Okay.
Never mind.
They're Pythagorean identities. Are those things in the denominator squared?
No.
No, so you cannot swap things out. So Kat, what would you do first? Like,
Could you change like both of the secants and the cosecant?
no, I mean,
to tangent.
okay.
I have,
I got a fraction plus a fraction on one side and not a fraction on the other. So, Sasha, what's your suggestion?
Multiply the left side by 1 plus secant of x and the right side by 1 minus.
Okay, so there's your start. Find the common denominator. So Sasha's saying multiply the first one by something and the second one by something. With your group, figure out what that something is while I attempt to do attendance.
Yep. Yep, you gotta write a pass.
So cause I wanna see some variations of how people are gonna do this, take a try. Group 8. So group 8, I would like, hey, you and Laura to put up what you're brainstorming up here. Group 4, so Chloe and Polly and Khalil. You guys could put up what you're thinking over here. Group 2. You guys. Group 2, if you could put your thoughts up here. Take one more video. And group 5, and you guys put up what you're thinking over here.
I can put up what I have.
So, Brianna and Zach can be our group 5. So group 2 is started, group 4, 5, and 8. 8, I hear you talking about it, so, yes, Sasha.
Oh, right.
Like, this doesn't make any sense. What do you think? I'm still, I don't know if I actually have this.
It's not gonna be equal 0, because, okay. Where we are with these guys, if I tell you prove the identity, it's gonna be true. Unless we have a typo, it will be true. In college, they'll be like, prove it if possible, and then you gotta know, like, maybe it's not it. So if you get that it comes out to 0, you've made a mistake. Volunteered to write on the chalkboard. You're the assistant, you are the one that's going to write. And I would like to see this step written. Actually, I will say this now. Could you all hear this? You must write that step. What did you do? Well, we followed what Sasha said was multiply by 1 to the first term, and multiply by 1 to the next term. What kind of one? Well, a weird one. She said, this denominator, we need to multiply by that over that on the first one. And the other denominator, we needed to multiply on the other side for each one, and thank you for those putting it up on the boards, fixing that, and showing your work. Aiden, you need to have the numerator. This needs to be 1 plus right? Yes, 1.
And then I just put them together, but
Because I'm here, so like here you be so
Is this equal to 1?
because here
You need to make this equal to 1. This is 1 plus This guy, you're multiplying by 1, no, you're multiplying by 1 minus secant
I
x.
accidentally started. Yeah, they would, Ronnie would start.
So split the cancel out.
Like I had a thought process, but
Holly? So Sam? Multiplying the two things in the denominator together, what are they? What does it come out to be? Okay, and that multiplied out, what is 1 minus secant x times 1 plus secant x?
1 over 10.
We're
flipping the 10 squared, so when you multiply, it has to be 1 over.
Okay, so we had a positive secant and a negative secant, he just skipped over that because we did a couple of patterns.
Because it's gonna be on the denominator, so it's gonna be
Yeah.
so make it 1 over.
So, put your head up.
you lost me.
So Polly, looking up here, does it have a common denominator? Do the fractions have the same bottom? They do, so what can I do? So how do they get put together? Yes? So it's 1 plus secant plus 1 minus secant all over 1 minus secant squared. Okay? Cool. So, guys, you cannot multiply both sides of the fraction by stuff, because the other side of the fraction is unknown. So you need to do this step of multiplying by 1 for a common denominator.
I feel like rewriting the show.
Okay.
I think that's
why it's
I got it.
Zach, how do I add 1/2 to 1/3? Find a common denominator. So do I just multiply the bottom by 3?
You have to do 3 over 6.
Okay, I need to multiply the bottom and the top by 3, right? And over here, I need to multiply the bottom and the top by 2. I'm multiplying by 1. So that's what you guys, so, yes, what you just said, this is 3 6 plus 2 6, so we get 5 6. Now that the bottoms match, we can do that. All right, so what you guys need to do over there, I need to make these denominators the same, and it's gross, where the example I just did had a 2 on the bottom and a 3 on the bottom. This guy has a 1 plus secant x, he's missing this factor of 1 minus secant x. So like you just said, I'm not just multiplying by 1 minus secant in the bottom, I gotta multiply the top as well. And here, this is missing 1 plus secant x, not just multiply the bottom but the top as well. So can, you guys see what I mean now, that needs to be fixed?
I'm gonna write.
Okay. So, looking at what Khalil has written over here, he has written up that, ooh, oops. He has 1 plus 1 up top is 2. Positive secant, negative secant, they go away. 1 minus secant squared. Leo, the identities. The identity that has secant in it is this guy. So what is 1 minus secant squared equal to, given this identity? So I get 2 over negative tangent squared,
Cause if it's like that.
and I still don't quite have the other side. Aiden, what do I have to do?
Well, I did 2 over negative times over x, and so did that one. This side is.
So the last step is to recognize that tangent in the bottom of the fraction, so Khalil, it changes name. It becomes cotangent when you move it up. So I get negative 2 cotangent squared equals negative 2 cotangent squared.
That is not right at all.
So as I said, this needs to be multiplied by 1. So the top was 1 plus secant and 1 minus secant. Well, yeah, all right, hang on, no. Guys, when I tell you what the end answer is, if you tell me, yeah, well, I got the answer, it's a proof. You need to show you can get from A to B through valid steps. Telling me, well, I know the end destination is here, C.
I just don't know how to get there.
Yeah, I just don't know how to get there, so I'm gonna make some stuff up in here then. No, that is not credit. Because if you're gonna wanna claim that, I'll be like, fine, we're back to simplifying. I won't show you what the other side is, tell me what it equals. I don't know that that's gonna go over so well. All right. Still chugging away. All right. Can you guys try this one? Maybe write it down. And this one, both sides stink. So as a class, I'd like you all to try. Brianna, which side do you want to start on, right or the left? Left. So they both stink. I want you guys to try it by working on the left. And groups that are to put up, group 10 over here. Okay, we're so close to being done, so we're good. You guys have a seat. Papers. Yes, this is. Oh my God.
Alright, so what's the first step?
Nine, I'd like you guys to put your attention up here, so, starting on the left side. And group 3, Pat, if you could erase that green one, you guys could try that. So while you guys work on doing the left side, I will do it with the right side. Hayden, what is secant minus 1 over secant minus 1 equal? 1. 5 over 5, I have 5 cookies to share among 5 people. If I'm being nice, everybody gets 1. I have secant x minus 1 cookies, whatever that is, over secant x minus 1 cookies, everybody gets 1.
Yep.
So you guys continue working on the left side, and you guys should be with your partner. And you guys should be trying to work on that one up there. Thank you. because you're supposed to work on the other side, not copy down what I've put out.
I'm just trying to figure out, because I have no idea where to start.
Okay, so, good point. All right, so the beginning of class, we spent looking at the pattern of how this factors. So, looking at this one, both sides stink. But I see this and this, they're that conjugate of each other. So multiplying by one, it's a weird looking one, but multiplying by the conjugate over the conjugate. Why am I picking that? If nothing else, I'm starting on the right side. Looking at the other side, I want this factor in the denominator. How do I get it there? I am going to force it. I'm gonna just create it. I can't multiply by one over that. I gotta multiply by one, so I need to do this over this. So what do you think, if you're starting on the left side, what do you think we're gonna multiply on the left side?
Or I think it's the same thing, over tan x, right?
Mm. Okay, that's the hard way to go. Looking at this, you need that thing in the numerator, maybe multiply by the conjugate. I will show doing the way you said, though. But multiplying this out, this is a plus b times a minus b, so I get a squared minus b squared. Looking at the identity, secant squared minus 1 is tangent squared, so I'm going to replace this with what it equals. One of the tangents reduces and it's gone. Okay, so others have started by trying to, all right, oops. So you guys took that advice of, well, I see a tangent on the other side, so I want to multiply by tangent on both sides. Okay, or top and bottom. My suggestion to you guys that, hold on, this side has a tangent all by itself. Don't multiply that out. Amy, what are you gonna suggest?
Multiply secant x plus 1 over secant x plus 1 times tangent x over secant x minus 1.
Okay, I gotta multiply by ones. I can't, that didn't sound like a one.
No. Secant x plus 1 over secant x plus 1.
Okay,
Times the original.
okay, and what I see other strategies on the board, they started this way, we'll try that one next. So, multiplying by tangent over tangent, we get here. What does tangent squared equal? Sorry. Secant squared x, minus 1. Okay, so I'm gonna get rid of tangent squared. What can I do to the numerator? No, that's going backwards. Like, factor. How does it factor? No squared. Secant plus 1, secant minus 1. Those guys cancel. And again, looking to the other side is your guidance. If you don't know that this is gonna factor, look at the other side and be like, I need a secant plus 1. Does this thing fit a difference of squares pattern? So that here I get exactly the other side. I get that secant x plus 1 over tangent equals secant x plus 1. Cool. So, forcing the denominator to look like the other side by multiplying by tangent over tangent works. I won't erase it. I will show the other one also. Hayden said maybe we start by doing what I said, which he's like, well, there's a secant plus 1 on the other side, so maybe I'll multiply by secant plus 1 over secant plus 1. And that the other side has that secant plus 1 up top. I'm gonna leave it alone, but secant plus 1 times secant minus 1.
Secant squared x minus one.
And
And that equals tangent squared x.
so tangent. And this was tangent squared.
And the tangents can divide, cancel out.
One of them cancels, and we get exactly what we were looking for. So, some of the issue is these, okay, it's now really hard because we're requiring you to have good ability of knowing the trig identities or being quick with using them, but it's also requiring you to have a lot of algebra. And now it's algebra with big funky functions. If you are uncomfortable with factoring things like a squared minus b squared, it's much harder when it's trig functions, tangent squared minus 1 and stuff. Okay. Okay. Can you guys do this? What is sine plus cosine squared?
So what do you get?
Sine squared x plus 2 sine x cosine x plus cosine squared x.
So I hear this, which is pretty much the pattern that Galila told us during the warm-up. Is anything else that I can do, or is it done?
Oh, wait. Sine squared x and cosine squared x is 1.
Sine squared plus cosine squared is 1.
Ew.
So we get that. 1 plus, yes. Sorry, it's 1, 1 plus 2 sine x cosine x. There was a problem hidden under there. Yep.